Okay, this is Andrew, and this is CS330. This is Project 1, the finite state machine. Okay, so I totally redid this project. I wasn't really happy with it the way I'd done it in this class before. Often people use like an elevator or something to do a state machine, but I really wanted to do something really IT related that would give you an idea about TCP and UDP, things we're going to be covering in this course. But I couldn't just do a TCP state machine, or you could just go on the internet and find one and copy it. So what I came up with is it's like a hybrid. We're going to create our own. Well, we're going to take TCP and modify it. So TCP is generally used like if you transfer a file, it builds a connection, and if any data is lost, so I'm transferring a file from one computer to another. The other computer knows how much data it's supposed to get, and if it doesn't, it requests to resend the lost data. So it's like it's connection, and it's pretty much guaranteed that you're going to get the whole file. UDP is like a Skype video where you do voice or video over, and if the data is lost, there's no point in resending it because the conversation's already gone. So I wanted to come up with a protocol that would be kind of in between TCP and UDP, so that we could make it just a little different so that you learn about TCP, UDP, state machines, and even more importantly maybe is just the concept of making your own protocol, because I've recently had classes after this that I've taught, and students are supposed to create their own protocol, and some of them just didn't even know what that meant. So this is going to get you on the start of that. So I think this is a great project. I'm really excited about it. Don't be overwhelmed by it because it's really not that complicated if you stay focused. Okay, so this just describes what you need to do. This comes right out of the rubrics, and so does this, so I'm not going to really read it to you. These are just cool looking pictures of state diagrams. So on to the problem. So like I said, I was trying to think, what could possibly be using that data, that protocol that I'm thinking about. And I got to thinking like radar that builds air traffic control, maybe even for the military. So basically it takes this data that it sees, all right, it detects planes out here in the air, the sky, and it sends that data back to the control station in real time, but there's no reason to resend it. I mean, if the plane's going Mach 2, there's no reason to send the data again. The plane's already gone. So, but you might want a more reliable connection than just a best effort. So that's what we're going to do. So if you read through this, so you're building on a contract for a military to help with a phased array radar. Okay, so a phased array, don't get too caught up in the radar, but basically you see there's no moving parts, and they use the electronics to steer the beam, so you can literally steer the beam into any direction you want electronically with no moving parts. And consequently, you could have 4 or 5 beams or whatever going at the same time, all in different directions at different frequencies. So that's what a phased array radar does. And if you read through this, you can see it's been determined TCP is too slow and UDP is not reliable enough. So a hybrid protocol will be designed. Okay, so we're going to call it CTU, will be the hybrid protocol. Alright, so I'm not going to read through all this for you. You can read it. This is TCP, okay? And we're going to go over TCP more in the course before this project's due. So, read through this, pick up what you can, but don't panic. This is what a table that gives you the state description, the event, and transition. So read through that. You'll see all those. You'll see through all those, and then here's the state table, right? So really what you're going to do is basically this beginning part will be very similar because you're going to do a two-way handshake, not a three-way handshake. You're just going to do SYN and ACK, okay? Now come over here, and this is getting more detail of the problem. So basically, you have three RF receive conditions for the radar. One is condition 1, 2 is condition 2, 3 is condition 3, and then there's a situation where no target is detected. Okay, so condition 1 is target detected. Okay, so connection from the radar station, the control station opens, else it's closed. Only a two-way handshake will be used. If a target is present in beam 1, data is transmitted every 20 milliseconds for 5 milliseconds. If a target is present in beam 2, it's transmitted every 20 milliseconds for 10 milliseconds. While in this condition 1, the output condition, a danger output condition, is moderate. So after 100 milliseconds, the link is closed, and by the control station, and you want to use FIN-AC. Okay, I'm not really saying which one you have to use is the server or the client, so that's up to you to choose. Condition 2 is the connection from the radar opens, else it's closed. Now, if condition 2 is detected and 1 was already running, then 1 will shut down. Condition 1 will be shut down, and it'll transition right into condition 2 opened. And again, only a two-way handshake is used, FIN-AC, if a target is present in any beam. So there's two beams. There's two beams for each condition. So if it's present in either beam A or beam B or B1 or B2, whatever you want to call it, then data is transmitted from the radar to the control station. That, when I say data, that's like data the radar is taking about where the plane is, image data, things like that. So every 25 milliseconds for 10 milliseconds. If 3 consecutive cycles of condition 2 are observed for a total of 75 milliseconds, an alert is triggered. Okay, after 100 milliseconds, link's closed. So the third condition, you can probably guess by now, if condition 3 is detected, at any time 1 and 2 will be closed and 3 will be open. Two-way handshake. If a target is present in both beams, data is transmitted every 25 milliseconds for 10 milliseconds. If 3 consecutive cycles of condition 3 are observed for a total of 75 milliseconds, an alert and an auto strike is triggered. Okay, after 100 milliseconds, the link is closed and by the control station. And if no target's detected, it's just basically in a wait condition and, putting out that it's a secure status. Okay, so it's your job to create a table like 151 in the TCP model, include state descriptions, events, and transitions, all inputs and outputs, state diagram, time and dynamic diagram, and full explanation. Looking also how this increases the reliability over UDP but decreases the amount of time that it's used for the connections compared to TCP. I will say that not everyone could get 100 and their paper could be a little different. Obviously the logic flow of the conditions should be basically the same, but part of this is a little bit of design. So how you use your flags, your syncs, your finish, things like that is going to be your design. I gave you some good ideas of how to use it here, and basically you're going to copy off the TCP that I put in here, and you can look up UDP online and copy some out of that too. So other than the two-way handshake, okay, and these conditions, everything else would be borrowed from TCP or UDP. So, like I said, I think this is a great project. I'm excited about it. It is beta. I haven't used it before, so if it turns out that it's just not going to work for us, then we'll figure out something else to do. But, yeah, I'm pretty excited about it. I think it's a good project. Like I said, I think it's going to, once you work through it, you're going to have a good understanding of TCP, UDP. You're going to have an idea of how to design protocols, and you're going to know what a state machine is. All right, so thanks a lot. I hope that really helps you out and enjoy doing the project.